So who's ever heard of a rational expression before anywhere? Yeah, one person has? Two people have? Okay. All right, are you guys ready to go? Need more, a little bit more time. All right, sweet. All right, so I'm going to start over here with you, and we're just going to explore. All right, we're just going to explore. What I have over here on this left-hand side is right here. I want you to concentrate on this part, okay? Who can read that to me? What does that say? What does that whole part on the right-hand side of the equation say? Someone just read it out loud. Anyway, go ahead, yeah.
F of x equals x plus 1 over x plus 3.
Good. He said f of x equals x plus 1 over x plus 3. All right, great. If I was just to focus on the top part, right, the top part, the x plus 1, that's a polynomial. You guys agree with that? That is a polynomial, right? And what type of polynomial is it? It's a binomial. Good. And if I were to concentrate on the one on the bottom, x plus 3, what type of a polynomial would that be? Another binomial, right? So another polynomial, right? I want you to consider that whenever you have a polynomial divided by another polynomial, that's going to be a rational, a rational expression. So all it is just something, it's a polynomial over polynomial. And this is an example of one, x plus 1 over an x plus 3, okay? So now, but before we do this, okay, before we get into this, take a look at this part over here. This says f of 0 equals 1/3. Can someone look at this and try and figure out how did the computer calculate that f of 0 was 1/3? What did they do? These two things are related somehow. My rational expression, x plus 1 over x plus 3, and f of 0 gives me 1/3. What do you think? What do you see?
You would plug in the 0 to the x value, and it cancels the x's out, so it's 0 plus 1 over 0 plus 3.
Yeah, he said f of 0 was 0 plus 1 over a 0 plus 3,
That gives you 1/3.
and that just gives you 1/3. Who agrees with that? Is he right?
Yeah.
Okay, well, if he's right then, what would f of 1 have to be? When I plug this in, what's it going to be, guys? 2/4. Did we get 2/4? Yes, we did. Okay. What would f of 2 have to be? Who says 3/5? Do we agree? Okay. Did we get 3/5? Yes, we did. How are we getting the 3/5? Who can explain it? How can we get the 3/5? Only one person in the room can explain how we get the 3/5 out of this? 2 people in the room? 3 people in the room? 4 people in the room? Okay, what do you got? How do you do it? Yeah. Hmm. Okay, so fair enough. Okay, here's the next question I have for you, and this is where I'm going with this. This is the most important question. Okay, if I ask you to evaluate f of -3, and I ask the computer, what do I get there? I have -2 over what?
0.
Okay, over 0. Anybody notice anything about that?
It's over 0.
It's over 0. Okay, am I allowed to actually have that? Okay, so watch this, right? When I make this, oops, sorry, let's see. When I ask the exact expression for this, notice, what does it give me? Undefined. Why? This is the question. Why is this undefined? Why does this give me an undefined? And it has something to do with the fraction that you just saw a second ago before I put that double arrow in there. Why is this undefined? Who can explain why it's undefined? Okay, this is where we're at. No one in the room can explain why the computer is so upset with me right now because it's undefined. Because it can't be over 0. What happens if I plug in f of -3? The math looks like this. -3 plus 1 over -3 plus 3. Is that true? That gives me, what's -3 plus 1? -2 divided by 0. And that is undefined. And why is that undefined? Because I have a 0. Are we ever allowed to divide by 0 in mathematics? No. We can never have a fraction on the bottom. So that means that there's something very special about this number here, this -3. Okay? And what that means is that this number, this -3, this is going to excluded value. Now, you don't have to write this stuff down. I just want to explore with you for a second. So I want you to try and find the excluded value for this expression I'm going to give you. Okay? I'm going to give you f of x is equal to 3 over x plus 1. What is the excluded value? Think about it right now. Think about it. What is the one value that I would plug in that would give me undefined? Okay, raise your hand if you think you know. One person, two people, 3, 4. Raise your hand if you think you know. What number would have to give me a 0 on the bottom? 2, 3, 4, 5, 6, 7, 8, 9. Renee, what number would it be, buddy? -1. Renee says -1. So if I ask the calculator f of -1, it should give me undefined. We got to see. Is he right? Oh, I didn't do it right. The suspense is just killing me. F of -1. Hey, undefined. He is 100% right. All right? Let me give you one more. Find the excluded value. If I gave you f of x was equal to 2 over 3x. Well, not 3 to the x, 3x. All right? What is the excluded value for that one? What number can you not plug in because it will give you a 0 on the bottom? One person knows, 2 people know, 3 people know, 4 people, 5, 6, 7. Brentley, what do you think it is? 0. Why do you say 0? You're right. Why? Yeah, you got it, right? So if I ask f of 0 and the calculator, it should tell me that it's undefined, and of course it is. Okay, good. Let's head back over to our notes now, all right? So rational expression. Okay, so the definition for us is a polynomial over a polynomial. That is a rational expression. All right, so I want you guys to make up a rational expression. Somebody make one up. Give me any polynomial over another polynomial. Anybody in the room can make up their own. Just yell it out. What would it be? Yeah. X plus 8 plus 12. Is that a rational expression? Yes, it is, because I have an x plus 8 over an x plus 12. Check. I agree. Give me one that has a monomial in it. Give me one that has a monomial in it anywhere.
F of x equals
X plus 3? Oh no, over 2. X plus 3 over 2. Is that it? Yep, that's a rational expression. That's a polynomial over polynomial. Good. Give me another one. Make one up. Give me one that has a quadratic in it. Ooh. X squared plus 3 all over 2. Good. Give me another one that has 2 quadratics in it. Polynomial over polynomial. Give me another one. Yeah. Okay, x cubed. Good. I got you. Yeah, what else? 4x squared over 2. You guys like that over 2 a lot. Give me another one that has 2, that has a quadratic in the top and the bottom. A quadratic in the top and the bottom. Make one up. Somebody new. You can make up your very own. Anything you want to make up from your brain. Whatever your brain can make up. Yeah, what do you got? Yep. Awesome. Awesome. That's another rational expression. All of these, every single one of these are rational expressions because they're a polynomial over a polynomial. So, a great question for us to come back to and say it'd be like, what is a rational expression? Okay? Is the essential question that we're trying to answer. What is a rational expression? You should be able to answer that question by now. It's a polynomial over a polynomial. All right? Now, here's what I want to do. We're going to find the exclusion. All right? I'm going to give you a rational expression. I want you to find the excluded value. Here's the first rational expression. A. It's going to be x plus 8 all over 10x. All right, what is excluded value? Who thinks they know what it is and why is it? I got one person who knows. I got 2 people who know. Now remember, we're looking for the undefined part. So remember, back over here, what was the thing that was undefined for us? The excluded value. Okay. Michael, what do you think it is, buddy? Yeah, why do you say that? Right. So the way that we write that, we say x cannot be 0. Very, very good. Okay, here's B. Find the excluded value. This one. 5 over 2x plus 1. What is the excluded value for that one? 5 over 2x plus 1. Anybody see it? Brendan, what do you think it is? No, I don't know. What do you think it is? 0.5. You are really, really, really close. Okay, why is it negative 0.5? How'd you do that? Yep. It's negative 0.5. Yeah, so you know what the trick is? You set the denominator, this one, 2x plus 1, you set that equal to 0, and you figure out what x has to be. So if we subtract 1 from both sides, then I get 2x is equal to negative 1, divide by 2. So x is equal to negative 0.5, and Kyle came up with 0.5 on his own in his head. But that's how we do it. So x can't be negative 0.5, or you can just say x cannot be negative 1/2. Either one of those two things are fine. All right? Kyle, very nice job. Let me give you guys another one. Give me a 3 over, how about x minus 5? What's the excluded value? What's the thing it can't be? Sasha, what's it going to be, buddy? 5. Yes, x cannot be 5. Very good. Awesome. And the last one. Right now, work with your partner or work with someone next to you. What does the excluded value here? If I gave you 7 over 3x plus 2, what is the excluded? People are missing this concept, like, greatly, okay? So, check it out. Let's back ourselves up. Please look up here. Michael, you ready? Okay, look. If x was equal to 0, if x was a 0, what would this whole thing have to be? It would have to be 7 over 2. How do we do that? We do that by saying this. 7 over 3 times 0 plus 2. That's equal to 7 over 3 times 0 is how much? What's 0 plus 2? 2. That gives me 7 over 2. Okay? And is that okay? Am I allowed to divide numbers by 2? Yeah, that's fine. I can divide numbers by 2. Okay? What if x was equal to 1? What would my value be? What would this be? It'd be 7 over 3 times 1 plus 2, which is just 7 over 5. Am I allowed to divide numbers by 5? Yes or no? Yes. What's the only number I'm not allowed to divide by? 0. So a much faster approach, don't you agree, is just take this bottom part and set it equal to 0. 3x plus 2, figure out, okay, well, it can't be equal to 0. Right? And then just figure out what x has to be. How would you solve for x? How would you isolate x? We're back to, like, first week of school. Yeah, so 3x would have to be what? Negative 2. Can't be negative 2. Then what do? Divide by 3. Divide by 3. So x cannot be what? Negative 2/3. Okay, that's my excluded value. You see it now? You really see it now? Okay, convince me, everybody in the room, convince me that everybody in the room can do this next one. We'll do E now. Convince me. Okay, if I give you x plus 131 over 2x minus 5. Excluded value. Okay, I gave you this. F of x equals x plus 131 over 2x minus 5. And somebody said to me as I'm walking around the room, I don't know what to do with the top part. Who cares? The top part doesn't matter because we're dividing by 0 or dividing by something, right? So what's the excluded value? What'd you come up with? F of what? 5 over 2. How did you come up with the 5 over 2? Whoa. There you go. So when I plug this into the calculator or the computer, what should I expect it to see? Undefined. Let's see here. If I go 2 answers here and I go like that, I would expect to see undefined, right? So the top part doesn't matter at all, right? Even if I change that x to a 3x, it would still be undefined, right? Even if I change this to 101,315, it would still be undefined. It doesn't change the value of it because we only care about the bottom of those things, okay? Okay. Since a rational, whoa, we're not already yet. I can say. There's a fraction, 8 over 10. Is that fraction in its simplest form? No, it's not, right? So this concept is the exact same concept that we're going to do with rational expressions. It all starts with fractions. Now, how do I know that that's not in simplest form? 8 over 10. How do you know that? Yeah. Oh yeah. So let's go ahead and break this up into its prime factors, right? So 8 is 2 times 4, but 4 is not also not done yet, right? So yeah, 2 times 2 times 2, yeah. And then what's 10? 5 times 2. Yeah, 2 times 5. Okay, now, question to you. Are we multiplying everything on the top? Look at it. What does it say? It says 2 times 2 times 2. Are we multiplying? Yes. Yes. Yes, I could. I'm going to get there in 1 second. But I want to break this down first as far as I can go. Then, what's 2 times, and then, am I multiplying everything on the bottom? Yes. So if I am multiplying and multiplying only, am I then allowed to cancel those out? Yes, I am. And then just like she says, 2 times 2 is just 4. Can't do anything with that. And then 5 on the bottom. So I have 4/5. That is in simplest form. Okay? You want to know the mistake everybody makes? Okay? They forget sometimes that you can only cancel if you're multiplying, not when you're adding. So as an example, right, if I had this, if I had 8 plus 1 over 10, could I do this? 2 times 4 and then do this, 2 times 5 and then cancel the 2's? Can I do that? No, I can't. But you'd be amazed, and I guarantee you somebody in here is going to make this mistake, how many people do that all the time, right? So, when we have a rational expression, we're going to simplify it. The steps are we're going to factor, and then we're going to cancel. All right? So, let me give you an easy one to start off with. Okay? So, we're going to simplify. And we're going to simplify this. We're going to simplify x all over 3x. All right. Is the top part a polynomial? Yes or no? Answer the question. Is the top part, is the numerator a polynomial? Yes or no? Yes, it is. What type of a polynomial is it? A monomial. Very good. Is the denominator a polynomial? Yes. What type of polynomial is it? Also a monomial. Good. All right. Am I multiplying everything on the top? Just x. There's just only an x there. Okay. Am I multiplying everything on the bottom? Does that say 3 plus x? No. Does it say 3 times x? Yes, it does. Can anything now cancel out? Okay. What two things can cancel out? Yeah. Now, why can you cancel those out? Because you're multiplying. And they make a ratio of 1, right? X over x is a ratio of 1. So, how do I simplify x over 3x? What would it be? If I had x over 3x and I cancel out, what am I left with? Very good. I'm left with 1 over 3. So, I have a simplified version of 1/3. This is an easy one. All right, let's do this one. What if I gave you 5x all divided by 5 times x plus 3? Okay, first we're going to factor it. Is everything factored on the top? Yeah, right, 5 times x. Is everything factored on the bottom? Yes, it is. 5 and then an x plus 3. All right, now, what can cancel? The 5 can cancel with the 5. Can anything else cancel out? No. Very, very good. You cannot cancel those x's. How come? Because your addition. Very good. So when I simplify this, what do I have left with on the top? X over what's on the bottom? X plus 3. Find the excluded value. What can x not be? -3. Very good. Awesome. All right. Let's give you another one. How about this? How about 6x to the third minus 12x squared all divided by 18x squared? Whoa. All right. Now, is everything factored on the top? Yes or no? Okay, we don't understand what factored means, right? Can I pull out the greatest common factor? Yes, what's the greatest common factor of 6 and of 12? 6, very good. So, what's the greatest common factor of x to the third and x squared? Very good, x squared. What do I have left? X minus 2. Very good. Now it's been factored. Very good. Because 6x squared times x is 6x to the third, and 6x squared times negative 2 is a negative 12x squared. Very good, Molly. All right, next. On the bottom, can I factor an 18x squared? Yes, I can. I can factor the number 18. What's the number 18? How do I factor the number 18? Factor 18 for me, guys. Okay, 9 times 9 is not 18. Okay, all right, 9 times 2. Okay, good. So 3 times 3 times 2. All right, good. But there's a 6 on the numerator, so could I say maybe 3 times 6? Can I do that? 6 times 3 times x squared. All right, now, what can cancel out? The 6 and the 6. What else? The x squared and the x squared. Good. What do I have left with? X minus 2 all divided by 3. Very, very, very good. All right, let's do a few more of these together. What if I gave you 8x all divided by 8x to the third plus 16x squared? All right, let's factor the numerator. 2 times 2 times 2, oops, sorry. 2 times 2 times x. What's the denominator going to be? What can I pull out of an 8 and a 16 there? Pull out an 8, very good. What about x to the third and an x squared? X squared, very good. One person sees this. Okay, what do I have left? X plus 2, very good. Okay, now, anything cancel out? Okay, so I have 2 times 2 times x. On the bottom, what do I have? Oh, wait, there was another 2 there, sorry. And then I have 2 times 2 times 2, and then an x squared, and then an x plus 2. Yeah, all the 2's can cancel out, right? What else can cancel out? Yes, this x and one of those x's down there. Very good, because I have 2 of them. So that gives me 1 on the top. 1, awesome. On the bottom, it gives me x over x plus 2. Very, very